In our last lesson, we looked at solving systems of equations with graphing, substitution, and elimination. Now, graphing was nice because it gave us a visual picture of what's going on, but sometimes we could not get the exact answer and we'd have to approximate it. Substitution and elimination allowed us to be able to get the exact answer without having to do any approximations. Now, a fourth way in which we can solve systems of equations is by using matrices. Now, for the most part, I'm going to just tell you what you need to do to be able to solve a system with matrices. We're not going to go into all the mathematics of matrices and how that works. For the sake of what we need for our state standards and the MCAs, um, we're not going into that. Now, when you're looking at solving a system of equations by matrices, you want to make sure both equations are set up in the same form. Typically, you want your variables to be in alphabetical, going from left to right. The normal number needs to be on the other side of the equal sign. So your variables on the one side, typically alphabetical, equaling a number on the other side. Now, matrices have square brackets. So we're going to have a matrix for the numbers in front of your variables. There's a 1 in front of this x, a 3 in front of this y. So that's why I have a 1 and a 3. There's no plus, there's no comma, there's just a space in between. Next one down, there's a 1 in front of the x, a 2 in front of the y. So I'm going to put that underneath. Our next matrix is our variable matrix, which is the variables that we were dealing with, which were x's followed by y's. So it's x's with y's. And then on the right-hand side of the equal sign, we want to put those numbers down. We have a 3 with a 7 underneath. Now, the first matrix here with variables in it, we're going to put in the matrix A in our calculator. The last matrix with numbers in it, we're going to plug into matrix B. So we're going to use our calculator. We're going to go ahead and plug this in. So we're going to go ahead and go second, x to the negative 1, which is matrices. I'm going to go over to edit. I'm going to select edit because I need to type in my matrix. And it ends up being 2 rows and 2 columns. So I'm going to go 2 by 2, which mine already is. So now I need to type the numbers in just as I see them. A 1, a 3, a 1, and a 2. Now I have that typed in, so I need to quit. Now I'm going to go ahead and type in matrix B. So I'm going to go back to matrix. I'm going to arrow over to edit. Now I need to go down to B. Now I'll hit enter. And I have 2 rows going across, but only 1 column, so it's a 2 by 1. So I'll type that in, 3 and a 7. Now I'm going to go ahead and quit again. Now I need to get A inverse B to show up. So I need to go back to matrix to get the name of matrix A. So underneath names, I'm going to hit enter because A is already highlighted. I need to do that -1 button, which is just my x to the -1. And now I need to go back and get matrix B. So I'm going to go back to matrix, go down to B, which is underneath names. Now I'm going to, excuse me here, hit enter, and I get 15 and -4. Now notice x is what's on top, y is on the bottom because that was our variables in that order. So my answer would be the point of 15 comma -4. So these 2 lines, if we cross them, would cross at the point of 15 to the right and down 4. Matrices are also nice when you get to more than just 2 equations and 2 variables. If you have 3 equations with 3 variables or 4 equations with 4 variables, matrices are the fastest way to solve these. So you want to make sure each equation is set up in the same form. Letters need to be in the same order. Normal numbers need to be on the right-hand side. So we're going to go 2, 3, -5. Then we're going to have 7. We have no b's, so that's a 0, and then a 3. A 3, a -6, and a 1. Our variables, so it needs to be the order that they show up in our problem, which is A, B, and C. And then the normal numbers on the right-hand side. All we're going to do now is just type these into our calculator. So I'm going to go to Matrix. Oops, Matrix, not Math, sorry. Over to Edit. I'm going to edit A. It's a 3 by 3, 3 rows, 3 columns. Type everything in as I see. And then once you type these in, double check to make sure you have everything correctly. And also double check when you write this down to make sure that you did not drop a negative. And so double check it. Then you can go ahead and quit. Go ahead and enter in matrix B. So arrow over to edit, down to B, hit enter. It's a 3 by 1. Then hit quit. Now A inverse B was the last thing I had, so I'm going to just go up and select that, and I'll hit enter. Oh, I get nice messy decimals. But that's okay because my calculator can handle decimals and turn them into fractions often. Not all decimals turn into fractions, but some do. So to do that, I'm going to hit Math. Notice it says arrow into fraction, so I'm going to select that and turn it into a fraction. And so then I get my answer. Notice the top fraction has to be my A, the middle fraction has to be my B, the bottom fraction has to be my C. So I get the answer of this. Now I could write this as an ordered triple. It would have to be in alphabetical order, so I would get the following. So here's my ordered triple, which would be a point in space. How far to go left and right, how far to go forwards and backwards, and how far to go up and down in space from a given point. Now here we could type this one in, set up our matrix equation, type it into our calculator, and in this case our calculator is going to give us an error. Whenever your calculator gives you an error, you either have two equations that are representing the same line or they're being parallel. Whenever you're given those situations, there is no inverse matrix for that first one. So if one of these equations is the exact multiple of the other one, you then have the same line. If these equations are not exact multiples of each other, then they are parallel lines or different lines, and you would have no solution. And if they were the same line, they'd be dependent and have infinitely many points in common.